Okay, good morning, guys. Let's begin, please. Last week we talked about the concept of science. What is science? And we went over that we have different types of classifications for sciences. We had basic sciences versus applied sciences. And after basic and applied sciences, that's a classification based on our objective when we approach the science. How do we approach that particular science? Are we trying to gather information, learn in depth knowledge that is getting the foundation and the fundamentals that would make basic science? And then taking the step further of the information that we gathered and the knowledge that we accrued in the basic science and applying it in technology and finding a real world solution based on the knowledges that makes it applied science. So basic versus applied science, that's an example of a classification of how we approach the science. So we have basic. So science can be divided into basic versus applied based on the objective. So this is an objective classification. The lab of a professor who's investigating an applied science is all about finding a technology, a machine, or a solution, or a medication, or the cure for COVID. You were applying the knowledge. While basic is to get the information that will enable me to find this real world solution. So that's an objective classification. Then we investigated the nature of the science. What kind of science are we investigating? So we said we have life sciences, and we had physical sciences. We had physical sciences, and what was the third one we talked about? Behavioral or social sciences. Behavioral or social sciences. Physical sciences are sciences of the studying the non-living. Excellent. So this is non-living, studying of the non-living. And we study the non-living, and in the sciences, what do we study in the life sciences? The living things. So here we study the living things. And in behavioral sciences, what do we study? The psychological aspects. But what did we say that we study in life sciences? Yeah, penalty. We look for the plus things and the minus things. Minus thing is the penalty and punishment. And plus, we look for the incentives and rewards. And these two come in play to guide what? These two. The minuses are our behavior. They guide our behavior. And we said that in the end, whether it's behavioral science, one, whether it's life science, two. An example of life science would be what? An example of life science would be what? Biology. Excellent. What we're doing here. Biology. That's an example of life science. What's an example of physical science? Astronomy, physics, archaeology, fossil fuel, geography. So you study things that are not alive. And we said all of these sciences, 1, 2, and 3, we approach them basic versus applied. There is basic astronomy, there is applied astronomy. There is basic biology, there is applied biology. There is basic behavioral sciences, and there's applied behavioral sciences. And now we have narrowed down. So now we are into the life sciences. And we said that when we investigate the life sciences, we have to have a scientific method. So the scientific method What was the scientific method? The scientific method was a procedure, was a conventional. It was a conventional procedure. It was a pattern that we have to follow. We have to follow this procedure to investigate all of the sciences, whether it's biological science, whether it's life sciences, or physical sciences, or the behavioral sciences. In the end, you have to have the scientific method. You have to have the scientific method. You have to have the scientific method. And this scientific method, we said, is a procedure we have to follow step by step. And we said that the first thing in the scientific method is what? Observation. Very good. Somebody said hypothesis. That could not be any more wrong. So you are not paying attention, because we said you can never have a hypothesis if you don't have an observation. I mean, somebody who is in a prison cell, somebody who is locked up in a prison cell, what do they observe on daily basis? They don't observe nothing. They are in a four-walled room. So they don't observe nothing. So do they get any hypothesis? So they don't have any hypothesis. You will never get a hypothesis unless there's an observation. And we said that science, there's a lot of serendipity in science. Where, remember the story of Isaac Newton and how he discovered gravity. He saw the apple fall down. He saw it. So that's an example of observation. So then he made a hypothesis that there's gravity. You walking in the street, you hear somebody screaming for help. There's fire in their house. So you make a hypothesis. There's a fire burning in the house. You need to call the fire truck. You walk in the street, you see somebody fainting or bleeding on the sidewalk. So you make a hypothesis that they need ambulance. So you will never have a hypothesis unless you have an observation. So the observation is the center of the scientific method. And you will never have an observation unless you had senses. So the sense lead to the observation, and the observation leads to the leads to the hypothesis. And we said the hypothesis comes in two forms: if, then. And we said, I observed that my car is not starting up in the morning. So a hypothesis is, if my car is not starting up, then maybe it ran out of gas. If my car is not starting up, then maybe the transmission engine is not working. If my car is not starting up, then maybe the battery is not working. So these are three hypotheses. So then when you made the hypothesis, you need to investigate the hypothesis. So, you go ahead, take out the battery, and bring in a car that is already working, and you replace that good battery with your bad battery and take their good battery into yours. If your car start up, that means it's a battery problem. But if their car, when you replace your battery in their car and their car start up but yours doesn't, that means it's not a battery problem. Then by process of elimination, you move on to the second hypothesis. Maybe now it's the gas. Then you look in the gas tank, it's full. So you see, then that's the second process of elimination. You say, okay, the third one is that definitely the main problem is that the transmission failed. So here you went from hypothesis into investigation. And we said when we investigate, we have to ensure that this hypothesis is testable and falsifiable. So the hypothesis has to be testable and testable and falsifiable. Testable meaning I can examine it. in the lab. I can measure. I can have an independent variable. I can have an independent variable, and I can have a dependent variable. So I can measure, testable, measurable. I can have a measurable independent variable and a dependent variable. I cannot come up with a independent variable I cannot even measure. I can measure the sunlight and I can measure the plant growth. So I can measure the ultraviolet radiation and I can measure how long my plant got. But I cannot measure if God is upset with me or if God is happy with me or not. But that does not mean that non-testable things do not have influence. Please remember this point. I said this last week already, that just because you cannot test it scientifically, it doesn't mean you can't rule it out. So for example, somebody believes there's a ghost in the haunted house, or believe in the black magic, or believe in God. That does not mean there are no ghosts, there's no black magic, there's no God. We never said that. It just means it's not scientific. But it could be true. But it's just not scientific. People think because it's not scientific, it doesn't exist. No, it exists, but we cannot test it. So your hypothesis, the scientific hypothesis, has to be testable. And the second thing, it has to be falsifiable. I can prove, like that battery. My hypothesis was the battery is not working. I can falsify that. If I put the battery in another car and the car start up, then I falsified my battery, that my battery is working. But if I can never test it, if I can never falsify it, if I can never ensure that it can be falsifiable, it cannot be a scientific hypothesis. And I make sure that I must run an investigation. In my investigation, I must have an experimental design. I must have an experimental design. And in this experimental design, I have to have an experimental group. I must have an experimental group. And this group, I'm testing on it the effects of what I'm investigating. I want to investigate the effect of a drug in lowering the blood pressure. I want to see if the blood pressure is going to go down or not. So I'm going to make two groups. Group one, you guys are group one, and you guys are group two. One group, I'm going to give them the actual drug, and the other group, I'm going to give them like M&Ms or maybe a capsule full of water. But remember something very important. Both groups are the same. So all of you guys are going to be patient with high blood pressure. I'm not going to bring one group who have high blood pressure, the other group doesn't have blood pressure, and I give both the medication. I violated the rules. They have to be the same. Everything the same number. Both male, both female, the weight is similar. Everything is as much equal as possible, except what I'm testing. So I'm testing my medication. I'm testing the effects of metoprolol. So I keep everything the same. You guys are in the same room, the same air conditioner temperature. You have the same nutrition. You have the similar weight. You are the same gender. You are the same age. You are the same everything except that one and only one. I cannot test two things. It is not going to be a control group. So the difference between the experimental, I hear somebody talking while I'm teaching. So there is control group. So the question is going to be testing whether or not you know the difference between experimental and control group. And both of them are important. You cannot give the medication to all the hypertensive patients, and the blood pressure goes down, and you conclude that's it. You know that my medication is is working because the blood pressure went down. You did not have a control group, because now the medication is not the only force that led their blood pressure to go down. It may be something else. But when you have a control group, you reaffirm that it was your medication, because both groups had everything the same. The only difference is the medication. But when you don't have a control group, you can attribute everything to bias, you can attribute everything to error. So the control group is very significant part of your investigation. And then after the experimental design, we have our experimental group and the control group, and that will give us the result. So we have charts. We label our results in charts and in tables, in charts and in tables. We have charts and we have tables. And we, yes, no. So if you are testing the effects of the one medication, metoprolol, on blood pressure. So the experiment is all about that medication. So I cannot give them metoprolol and hydrochlorothiazide. These are two medications. So I'm testing one. I can test the other one another time, but I cannot test two things in one experiment. Always test one. Sometimes they test two things, but it's a very complicated set. But for basic science, we're just doing one variable. I'm testing. So I keep everything uniform. One group, I can have multiple experimental groups, but my control is gotta be there, one control group that has everything identical to the experimental. The only different thing is the what I'm testing. So in that case, the medication. In other cases, I'm testing other things. And after I do my experiment, the control is the experiment. I'm experimenting in a control group. I don't give you your medication. Now are you gonna go to sleep or not? To see. I give you the medication, what time you were able to sleep. And then I get the results. In my results section, nothing but my chart, nothing but my table, nothing but my figures. I just outline them and describe what this is. This is a table, you say table 1.1. Yes. You make a table, there are different ways we outline our results. You make a table, and on the table, you outline. You put, for example, I don't have an experiment in mind, but let's say we want to see the effect of the blood pressure medication on their blood pressure. So you're gonna have a table that says the patient number. So that's patient 1, patient 2, patient 3, patient 4, patient 5, and patient 6. Then you're going to say they got a medication on day 1, day 2, day 3. Then you look at patient 1. What was their blood pressure on the first day? Blood pressure on the second day, blood pressure on the third day. You do this for the 6 patients. Yeah, for each patient. You're testing every single patient. And you're testing the patients that are in the experimental group, and the patients in the control group. And you can do it in a table. You can do it in a graph. So you make a bar graph. We have different kinds of graphs. You can have a correlation. We will get into that. But for now, we're just agreeing that result, we just display what we got. We don't explain it. We just describe it. Then we move on. After the results, we move on to the discussion. So now we discuss what is the significance of the results that we got. These results that we have, how do these results affect my hypothesis? Do I have anything that happened unexpected? Did I notice what we noticed? We notice. We label what we interpret. We do interpretation. we interpret what we have seen. We compare, we do a comparison. We compare what the experimental group versus the control group. We do the comparison. So the discussion is where we tie things together. We tie back to the hypothesis, we tie to what we saw in the results, we describe the experimental design. Did something unusual happen? The control versus, so we describe what happened. Then in the conclusion, we come up to what we concluded, that metoprolol significantly brings down the blood pressure. By how much? By 5 points, as seen in the results section when compared to the control group. The subjects who took blood pressure medication, their blood pressure went down by 5 units, as seen in table blah blah blah, and then you give your proof. You conclude that, and then after the discussion you have the conclusion, and after the conclusion you have the peer review. So the peer review, who are the peer review? Peer review are the excellent. These are the experts. So these are the experts who are your colleagues who will examine. They will examine and they will inspect. They will inspect your entire experiment and come up with alternative, alternative, and give you feedback. It's very important. No experiment is perfect. So everybody needs input from expert, not input from somebody who is not in the field. So you have to have an open mind. You have to have an open heart, that your colleagues must have something to contribute to your life, something to contribute to your profession. So as nurses, it's an interdisciplinary field. You're not going to be working only with nurses. You're going to be working with physician assistants, with providers, with specialists, with um, human resource social workers. It's an interdisciplinary field, because now treatment is not just, you don't just treat the patient who has a liver disease as a sick liver. You treat them as a person. You don't treat a woman with breast cancer as a cancer, as a breast as a breast with cancer. You treat her as a human being holistically. So treatment that is holistic requires interdisciplinary effort. So now that we have our roadmap, this is our experimental design. Now we're gonna move up to learn about life. So now no more behavioral sciences. Now no more this crude or non-living sciences, and now we're gonna talk about, we're now getting closer and closer into life. So the most important thing that we have to learn in life is what? Is the matter, the atom. That is the center of life, the nucleus and the periodic table, because these molecules, they are the center of our lives. Without molecules, no energy. No energy, no metabolism. No metabolism, the cell is dead. The cell is dead, the tissue is dead. The tissue is dead, the organ is dead. The organ is dead, the organ system is dead. The organ system is dead, the organism is dead. So it is the unit of life. So we always have to go in. So all of the discoveries that were made, they were made by using the scientific method to go in order, using the scientific method to investigate beginning from bottom up approach. So we have this triangle is very important. This big triangle is very important, and it begins from most basic and upward. So here you have subcellular structures. These are the atoms and the molecules. These are the atoms, these are the molecules, these are the organelles inside the cell, organelles, okay? And these are the subcellular. They are not themselves a cell, but they make us a cell. So you have an apartment. The chair is not the apartment. It is part of the apartment, but without it, the apartment will not make sense. You don't just buy an empty apartment. You need carpet, you need bed, you need kitchen supplies, you need the living room, the television. So these are the little things that make your apartment what it is, make it worthy. So the cell does not exist on its own. It exists based on top of this subcell. Below the subcellular, there's nothing. Even this was actually unknown. So this was discovered recently. They always thought that the cell is the basic unit of life, and it is. The cell is the basic unit of life. The cell, without the cell, you cannot have a functioning system. But they thought that we begin here. We begin with the cell. They thought the cell was the most basic. Actually, it isn't. It is the things that make the cell. So your car, without the gasoline, is not going to start working. It's not going to take you to work. Your car without the battery. So the battery itself is not going to carry you to work. The gas is not going to take you to work. But the gas in the car, the battery in the car is what's going to help the car. The car does not exist on its own. The car needs a substructures that make it what it is. And you're going to learn that all the diseases that happen up top here, somebody coughing, is not because the lung was sick. It's because the cells in the lung, they are so stressed. There's an infection. There is toxin. The bacteria is secreting toxin. There is poison. There is reactive oxidative stress. And that spreads, move upward like the fire. The fire begin with a spark, then gets bigger. People see the big fire, but they don't know it started with a little spark. So it is something that goes wrong in the subcellular compartment. That is what makes the cell in trouble. Then above the cell, you have the organ. You have the organ. Then the organ does not exist on itself. You have an organ system. You have an organ system. And the many organ systems work together to give you an organism. And many organisms give you the hmm? Muscle is an organ. So you have a tissue, you have a cell, you have a muscle cell, and many muscle cells give you muscle tissue, and muscle tissue with the nerves around the bone that gives you a musculoskeletal system. And the musculoskeletal system with other systems give you an organism. Many organisms give you what? Many organisms give you, yes, yes. Oh, yes, I forgot that one. Excellent. So after the cell, you have excellent job. Very good. You have the tissue, and then the organ, then the organ system, then the organ, then the population, guys. You have a population. You study the whole population. But you have to see that if I'm taking a medication, the medication is affecting some enzyme. The enzyme is not a cell. The enzyme is a subcellular compartment. The enzyme is a below the cell, subcellular compartment. Okay, proteins. Okay, lipids, fats. All of these things, they are subcellular, below the cell, but they make the cell what it, without them, the cell cannot be a healthy cell. So you need these little things that make the big thing happen. You know, the jigsaw puzzle, you know, the little pieces so you can have the big picture. So now all of our medications, they lactose intolerant mean? This microphone better been on the whole time. Was this light up the whole time? It was at some point, then it stopped. Oh, so now that means it wasn't working. And if it's not working, that means my sound. Oh my god. Okay, don't worry. I'm gonna give you a study guide, anyways. So now it's just enjoy and learn and pay attention. But the study guide is gonna help you. But this should have captured my sound. Anyways, so yeah. I will. So now you have two monos coming together to give me di. So now when they pair up, when the husband and the wife get married, the bond is called marriage. That's the name of the bond, is marriage. Some people, they don't have that kind of bond. They have a different